Well, let's write a program that will be able to read a switch and send the value out to an LED. So I've already started a program in assembler in AVR using the Tiny13, and in the hardware I have or I will connect a switch to port B bit 0. So port B bit 0 will be an input, and then an LED will be connected to port B bit number 1, and that will of course be an output. We will have the information or the value of the switch come in on bit 0, and then we will take that value and send it out to bit number 1, which will be the LED. So if the switch is high, then the LED will be turned on. And of course, if the switch is low, the LED will be turned off. In the code, one of the first things we have to do is to set the direction of the DDRB or port B. And this is done by an LDI R16. It'll be set to a base 2 number, and we want the let's see here, bit 1 wants to be an output, which is a 1. Bit 0 needs to be an input, which is 0. Then on the next line we're going to say out to the DDRB, comma R16. This will set the direction. Again, a 1 in the bit location means that that is an output, and a 0 means that it is an input. The next thing we want to do is to read the port, and the way you do that is by using pin B. So we're going to say in tab R16 comma pin B. This will grab all 8 bits of port B, even the ones we don't care about, all 8 of them, and this is now into R16. If we say the following, out to port B, comma R16, this isn't quite right. It'll be very close though. This would take those values that we had on the input and send them out to port B. The problem is that the information is coming on bit 0 and needs to go out to bit number 1. The way I've written it so far is that the information comes in and goes out on the same pins. But as you can see, the LED and the switch are 1 pin away from each other. So what I'm going to do is I'm going to rotate or shift the bits from the switch to the LED. And this rotate will be in the left direction because the LED is a higher bit position than the switch. So we don't want to do an ROR, that's going to the right. We want to do an ROL, rotate left, R16 by 1 position. And now the information will reach the LED from the switch. Right. This will occur just once. Well, let's do this forever. And to do this forever, we need a loop. So let's put a label here like top with a colon. Come down here and put R jump, which is a relative jump. And we're going to jump from here to the location called top. And now the computer will loop forever, reading the pins, read the data from the switch, and then write the information to the LED. And in between, we have the shift the data from position 1 to position 2. Alright, so this will work fine. Let's build it, make sure we have no issues. And let's see here, there seems to be an issue on line number 9. Let's go to line number 9. What did I... Okay. The ROL takes no operand, and it rotates only one position by default. So we don't get to choose how many bits we would like to rotate it by. So I took away the comma 1, and now this is good. There is one slight little thing that we want to maybe address, and that is the switch is normally 5 volts when you don't press it. That means the LED is on when the switch is not pressed. And you might think this is backwards. So if you don't like this, what we can do is we can toggle the data once we bring it in. And the way you toggle a bit is by saying COM. This will take the ones complement of all the bits in R16, which will be fun. I'm going to build it one more time. The build is good, and this program will work fine once we connect the hardware. So it's a pretty straightforward program, works pretty well. Keep in mind that the DDRB must be set before the loop, and it determines the direction of the port, and that must be done before you use the port. Pin B is for reading pins input, and port B is for writing to the same port output.